Today we're doing problem 56, merge intervals. I'm just going to continue and keep doing some of the problems from the Blind 75 that I think are fun or interesting or that I've seen before in the past. So let's get into it. Given an array of intervals where intervals at index I equals start at I, end at I, merge all the overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So what does that mean? Let's just look at an example. It's a lot clearer here. What they basically want you to do is just merge any overlap within any of the intervals in this list. So the first example, we have 1, 3, 2, 6, 8, 10, 15, 18. This is a list of lists, right? Where each one is an interval marked with like a start and an end. We see here in the output, we no longer have 1, 3 or 2, 6. These two get merged into 1, 6. And then 8, 10 has no overlap, neither does 15, 18. So there's no merging here. And example 2 is pretty clear. 1, 4 and 4, 5 get merged into 1, 5. And it even says it's because they're considered overlapping. So what's the approach and how do you know when something is overlapping? Let's talk about it here. Let me drag this over. This is the example we just took a look at, the first one. And I think it'll be a lot clearer to know when something's overlapping if we kind of just graph this, right? So the first interval is 1, 3. The second interval is 2, 6. It's pretty clear that we know there's an overlap, but let's do something to make it even clearer so that when we're looping through and making our check, we know exactly what to check for, right? Let's consider each value. I'm going to call this A1 and A2. I'm going to call this B1 and B2. Right, let's say while we're looping through, we can consider these two values for each A1, A2, B1, B2, and let's even mark them here, right? This is A1, this is A2, this is B1, and this is B2. We can tell pretty clearly that the overlap happens here, right? But how do you know that? Well, it's when A2 is greater than or equal to B1. Wow, that is terrible handwriting. But when A2 is greater than or equal to B1, that means that we have an overlap that exists. And so we're going to merge the two intervals in question. But what do we use as the tail or the end, right? It's pretty clear that if we're going to merge these two intervals, what should be our start? Our start should be A1 in this case, right? So the start should be A1, but what becomes of the end? Well, here, a lot of people would think is, oh, well, we just use B2 because B2 is later. And you're right, but what if we have a case where A2's tail, let's say this is not 3, let's say this was 8. Right? So A2 is actually not here. If this is 8, A2 is actually over here. We might have a case like this, right? So if we just took B2 as the end, that would be wrong. We actually want to use the max of A2 and B2. We wanted to use the larger of the two values. So now let's talk about how we're actually going to go about this, right? One way to do it, and this is the way that I'm going to do it, is I'm going to retain this output. I'm going to keep up an output. And what that's going to do is the first thing I'll put in there is actually the first value, 1, 3. But before I even do that, what I want to do is actually sort our intervals list. And it's very convenient that right now it's sorted, but there's going to be cases where we can imagine if this is not sorted, it actually poses a lot of problems for our algorithm, right? Like it just wouldn't work because we would be dealing with unsorted values, and since we want to sort by the first item, or the A1 in this case, it just wouldn't work if you had like 8, 10 in the beginning. Then you wouldn't know which interval is supposed to come after it, so it's really important that we first sort. And what we're going to do is we're going to loop through all the values in intervals, and we're going to compare what we have in output to our current thing that we're comparing to. So what we would do is basically we grab the first value and stick it in output, and let's say we just start from 1, and we would loop through to the end of intervals, and we would compare. Remember, if A2 is greater than or equal to B1, what are we going to do? Well, in this case, A2, right, which is this 3, is larger than B1. So we're going to take the max of A2 and B2. The max is 6, so in this case we're actually going to update this to a 6, right? And just to make that clear, I go ahead and delete this. So this becomes a 6. We move on. I is now here. It's 2. We're going to compare if A2, which is 6, is that greater than or equal to 8? It's not. So this check fails, and all we're going to do is actually just append intervals at index I into our output. We move on. I is no longer here. I is at the last index of intervals. We do the same check. Hey, is A2, which is 10, is that greater than or equal to B1, which is 15? It's not. So again, we just append, and we're done. So let's actually just start coding this, and it might make some more sense. So just like any problem, I think it's a good approach to first check your input. So if intervals is null, or there's not enough things inside of our intervals list, we can handle it. Let's just return here and do nothing, right? And again, like we said, first we're going to sort our input list, and we're going to sort it by the first value of each list within that list. So key lambda. We're going to sort by the first value. So if this is our list, we're going to sort by element 0 here. And we're also going to keep up an output. And what we're going to put in output is actually intervals at index 0. We're going to start with an item within our output, like we explained earlier. Let's use I to control our loop. And while I is less than, what are we going to do? Well, let's create A1, A2. A1 is going to be the last item in output, the last list, but the first element within that list, which is the start. A2 is going to be similarly the last item in output, but the last item of that list, which is the end. We're going to do the same thing with B1 and B2 here, but instead of output actually, we're going to use intervals. And instead of -1, which is the last item in intervals, we're going to use I. Because remember, I is the variable that's controlling which item in the intervals list that we're actually taking a look at the exact moment, right? So now that we have A1, A2, B1, B2, Remember our check from earlier, very simple. If A2 is greater than or equal to B1, if there's an overlap, then we're going to assign the output and the last item's last element, which is the end. So output at -1, -1 is actually going to be equal to the max of A2 and B2, right? Else, actually, this is not a curly brace, it's going to be a colon. Else, we're just going to append intervals at index I. When we're all done with this, don't forget to increment your looping variable, and then at the end we should just be able to return output. So let's check if this works. Great, let's submit it. Hopefully this works. Nice. So let's talk about the runtime and the memory usage. The runtime is actually going to be dictated by this sorting algorithm. We have a loop here on line 10, and let's zoom in a little bit, take a closer look. We have a loop here on line 10. It's just looping through every element in the list, starting with the first one. So it's basically O of n, but because of line 6, what we're doing is sorting. Sorting takes n log n time. That's longer than O of n, so that's actually going to be our runtime, is n log n. And as far as memory usage, I think it's potentially O of n, because we're maintaining this output. We created a auxiliary list here, but the worst case is that there are no intervals that we can merge, and so we're actually going to put every single item that we've already come across into that output list and then just return it. So yeah, hope that helps, and we'll keep working on the next problems in the Blend 75.